In this video, we're going to be going over Chapter 2, Section 1, Basic Set Concepts. So I'd like to first start off by defining what a set is. So a set is nothing more. So a set is a collection of objects with a common characteristic. In other words, the set has something in common. Now, we've all seen sets before, and maybe you didn't even realize it, but like, for example, this set right here, all right, is the set of even numbers. So 0, 2, 4, 6, 8, they're all even numbers. Now, there's a lot of things happening here, so I want to go ahead and describe everything that we have here. First, sets are always denoted with a capital letter. All right. Also, sets will always have the braces. Okay. Inside of these braces, highlighted in blue, these are all called elements. All right, they're all called elements. And those three dots are called ellipses, and they just mean to keep going. All right. Now, we have three ways that we write sets. So 3 ways to write sets. The first way is called the roster method. Sometimes we refer to this as the roster or the list method. And in this example here, all we do is we literally write out all of the elements within the set. Like this right here. Okay, so it's like reading a roster for a team or something like that. The second way, you can write it out in words if you'd like. So for example, if we had this set right here, all right, we could write this set as set D is the set of the days of the week. So Monday, Tuesday, Wednesday, R is abbreviated as Thursday, not so you're not being confused with T. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So in words, we would just say set D is the set of the days of the week. The last way that we do this, and this is the way that like mathematicians most prefer, is called set builder notation. Now with this set, let me use a different letter here. I'm going to use P. So the way that we use set builder notation is we first give it a capital letter, we give it an equal sign, and then we create our braces. Then we give a variable. So in this case, I'm going to write the letter X. Okay? Now, the next thing we write is this vertical bar. This vertical bar is read is such that. And then we assign a rule. So for example, this will be all the numbers of X that can be in between 1 and 5. And I'm going to say X is an element of the natural numbers. All right. So what this set is telling me is X is going to be any number I want it to be as long as it's in between 1 and 5 and they are natural numbers. So this is the set that I just built. So let's go over this one more time. First, we give it a capital letter. Second, we assign a variable. You can use any letter you want. Normally we use X. Next, you got this vertical bar, and that is read is such that. Then we have our rule. Now, I wrote out a lot of words here. Traditionally, this is how I would write the set in set builder notation. P is equal to X such that 1 is less than or equal to X, which is less than or equal to 5. And then I would write this. So these two things on the board right now say the same exact thing. All right, so let's go ahead and let's see what's a little bit different here. Well, I think you can see right here is the difference. This symbol is read is an element of. And then this symbol right here is the symbol for the set of natural numbers. Now, I will be using some of these symbols, okay, but I'm not going to write all these crazy math phrases or math sentences because I'm not expecting you to memorize all these symbols. But the ones that I do write, I want you to know. So like, for example, is such that, the vertical bar, definitely want you to know that. Is an element of? Yes, absolutely. We're going to be using that a lot. Okay? Now we're going to go over how sets can look. So we have 3 ways to write sets, but we have 2 types of sets. The first type is called finite. All right. So another way to say this is countable. Meaning, when you go ahead and you write the set, you can count how many elements are in there. So in this case, set T, defined as 1, 2, 7, 5, there are 4 elements countable. The other type of set are infinite. Now, obviously, that's not countable. And that would be like what I had earlier with those even numbers. And what makes this infinite are the ellipses, because that just means you just keep going. All right. Now, we do have one very special set. It's called the empty set. All right, and this one's very special. And the reason what makes it so special is you need to think about what a set actually represents. Remember, we defined it at the very beginning, and we said that a set is a collection of objects. Well, the empty set means there are no objects. So the empty set we can denote as a circle with a line through it, or the braces with nothing written. Now, there is one thing I do want us to know. Those two things do not equal each other. The empty set does not equal 0. 0 is a number. It's an element. Likewise, the empty set denoted with the braces, same exact thing. It is not equal to 0. They are not the same thing. Okay? Sometimes you will hear people refer to the empty set as the null set, meaning nothing. Okay? So picture like a room, nothing in it. All right, that's a good representation of the empty set. So now all I really want to do here is I just want to get us used to using set builder notation and the symbols and everything. So I can give you a question, something like, determine if the statement is true or false. So for example, here's the first one, letter A. So we have element R. Now, elements are lowercase letters. So R is an element of X such that X is a letter. Well, in this case, this would be true because R is a letter. So we're okay there. Now, what about this statement? Is 7 an element of the set 1, 2, 3, 4? Well, the answer is no. So what you would write is a line through that symbol is an element of. So we could say that that represents the phrase is not an element of. Very simple, very straightforward. Now we do have very special sets of numbers. We've already seen one of them, okay? We've seen the natural numbers. So I kind of just want to go over a couple more. So the natural numbers look like this. It has that special looking end. Let me try to write that a little bit nicer. There we go. So natural numbers start at 1, and they just keep going. The other set that sometimes people get confused with are called whole numbers. All right, now this has a special letter also. It's the letter W. Kind of looks like that. And notice the difference. The only difference between the natural numbers and the whole numbers is the number 0. That's it. Now, not to go too far down the road, but the reason why these two are different, if you think about how people learn how to count like children, all right? Look at your nieces, nephews, brothers, sisters, whatever. If you look at the way they count, they don't start at 0. They always start at the number 1. And that's because they can look at their hands. They could put up the first finger and say, well, that's 1. Then they go to 2 and 3 and so forth. Somebody, somewhere along the line of history, the history of mathematics, came and said, there's this new number called 0, and I'm going to invent it, and here's what it is. And that's really what it boiled down to. Okay? Now, a lot of the times we are interested in the number of elements within a set. All right? So we call this the cardinal number. All right? And the only thing that the cardinal number does is it tells us the number of distinct elements in a set. All right? Now we denote this as the letter N and then in parentheses A. And this is read N of A. That's how we read it, okay? So for example, and this is very easy. Let's say we have this set W, X, Y, Z. Oops. The cardinal number, N of A, would equal 4. Because we have 4 elements within that set. Like I said, it's very straightforward, very simple. You just got to know the definition. Now, the one that you do have to be worried about, all right, is if I ask you, what is the cardinal number for the empty set? Well, remember, the empty set has no elements. So the cardinal number for the empty set would equal 0 because there are 0 elements. Not the element 0, but 0 elements. All right? Now, sometimes you may have something that looks like this. You have 2 sets, and they both share the same exact cardinal number. So n of A equals 4 and n of B equals 4. When this happens, we call these 2 sets equivalent. All right, we call them equivalent sets. So equivalent sets means that the cardinal numbers are equal to each other. All right. Now, do not confuse this with the next thing I'm going to say. All right. Because the next thing I'm going to say are equal sets. Equal sets occur when set A and set B have the same exact elements. So if we look above, set A is 1, 2, 3, 8. Set B is WXYZ. They are equivalent, meaning they have the same cardinal number. However, they are not equal because they do not have equal sets. All right? Something like an equal set would look something like this. We're going to define C as 2, 3, 7, 8. D as 7, 2, 3, 8. Now, these 2 sets, as you can see, their cardinal number is 4. All right. And they have the same exact elements. Although in D, they kind of look backwards or they're all mixed up. Doesn't matter. These are both equal. And that's because they have the same exact elements. Okay, so therefore they are equal sets. All right, and that is going to be it for this video. See you in the next one.